Hi, so today I thought we would look at how to solve equations involving fractions. This will be part 1. There will be a second part in our next lesson.
So here's our first example, and what I'd like to show you is actually a little bit magical. What I'm going to do is show you my ability to make the denominators of an equation disappear. It's probably something you've always wanted to do, right? Is when you see fractions, is to make them disappear. Makes life a little bit easier if they're not around. So take a look and see. I'm going to show you what the magic looks like, and what I'd like for you to do is try to decode, because obviously it's math and not magic, and I'd like you to try to figure out what is it that I'm doing that's causing those denominators to disappear. So here we go. With the first question, I'm going to take the entire question and I'm going to multiply it by 4. What that's going to do is it's going to leave me with a few steps, but ultimately, as I simplify those steps, I'm going to get 3x plus 40 equals 24. And at that point, we don't really need to do anything with that because you would know how to solve that the regular way that we've been doing up until this point in the unit. Let's go see another example. So now we have two different fractions within the equation, and that looks a little bit more intimidating, but have no fear. I am going to make those denominators disappear once again. So this time I'm going to multiply the entire equation by 3. So after some steps and some simplification, I would get x plus 6 equals 5. And once again, you would know how to solve that equation by using the steps that we've done up until this point. All right, let's go see another question. All right, so looking at this one, now there are 3 fractions in our equation. Once again, don't worry, I'm going to make them all disappear all at once. This time, the magic's going to happen as I multiply by 8. And if I multiply by 8, what's going to happen? After a few steps and some simplification, I would get 7x plus 24 equals 2x plus 5. Again, how we got to that final step, not to be so worried about just now. What I'm wondering is, can you see how it is that I made those denominators disappear? What is it that I did that caused them to go away? All right, so if you think you've got it, if you think you figured out the magic behind this making the denominators disappear, I want you to think about what I'm going to do to this equation to make all 4 denominators disappear in one step. So I'm going to let you pause it to give it some thought for a couple of seconds. You might want to review back, pause the video, rewind a little bit, and see if you can find the trick. Once you can find the trick, then come back and press play and we will continue on. All right, welcome back. So if you thought you were going to multiply this entire equation by 30, you would be correct. So now let's take a look at what's actually happening that's making those denominators disappear. If you look at this equation and you think about the fact that now all of a sudden we have 30 having to multiply every single term of this equation, it's almost like we're needing to do the distributive property here. So we're going to be actually distributing this 30 into each one of the terms within the equation, just like this. All right, so what I've got here is I've got kind of a template for this idea that I'm going to take 30 and I'm going to multiply each of the terms of the equation by it. So I'm going to show the 30 being multiplied by the 12x over 5. And I'm going to show that 30 multiplying the 2 over 15. And that 30 is going to multiply the 1/30th, and it's going to multiply the x over 2. Now, it seems like a really big step that's happened right here, and I agree. It's kind of expanded it. That's what we do when we do the distributive property. Made it look a little bit more confusing. But if you remember back in our earlier units, we learned how to cross cancel. So this is a perfect opportunity to do it. I want you to look at how the denominators actually disappear here. Watch what's going to happen as I cross cancel. So 5 goes into here 1 time, and 5 goes into here 6 times. 15 goes into this denominator once, and 15 goes into this 30 two times. 30 goes into here once, and 30 goes into there once. 2 goes into here once, and 2 goes into 30 15 times. Take a look at those denominators. Do you notice how they've all turned into ones? So technically, we're not making the denominators disappear. We're turning them all into ones. And we accomplish that by multiplying every term in the equation by this number. And that number happens to be the lowest common multiple of these four numbers. So whatever your denominators are, find the lowest common multiple of them, meaning you need to find the number that each and every one of those denominators can divide evenly into, and then you multiply every term in your equation by that. After you've done that, you're ready to do that simplification step. And this is what I was writing out earlier when I was pretending that I had magically made the denominators disappear. So what we're going to do is multiply the numbers that have been left over after we've cross-canceled. So 6 times 12x is going to give us 72x. 2 times 2 is going to give us 4. We'll keep our equal sign. Now on the other side of the equal sign, 1 times 1 is going to give us 1. And 15 times x is going to give us 15x. And now we would solve the rest of this equation by collecting the like terms onto the same side of the equation and simplifying from there. So just to work that through a little bit and just to remind us about those steps, I know that I'm going to have to move this 15x across the equal sign so that it can be with the 72x, and I'm going to have to move this plus 4 also over across the equal sign to be with the plus 1. So as we do that, what we're going to wind up doing is having 72x minus 15x equals 1 minus 4. What that's going to do for us, it's going to give us minus 3, and we're going to have 57x left on this side of the equal sign. From there, we're going to divide by 57 for both sides, and that's going to give us x is equal to negative 3 over 57. And we'd leave our answer just like that. I hope that helps in trying to figure out how we can get rid of the denominators. We call this clearing the denominators, and it's a really helpful skill when you don't want to deal with the fractions. Now, of course, if you wanted to deal with the fractions the old-fashioned way, you could have forgot about doing the multiplying by 30 and just found a common denominator for all of the fractions and worked with the fractions the whole way through. There's two different models of those methods shown in your course notes, and you can compare them and decide the pros and cons of each method. Ultimately, this idea of clearing the denominators is going to be a really helpful strategy for you moving forward in math. So hopefully you can understand it. Don't forget to post questions in the discussion board. If you want to see another example, all you got to do is ask. Have a great day. Bye-bye.